Hi, Assalamualaikum warahmatullahi wabarakatuh, and good morning to all. So it's good to see all of you again. And today, I'd like to share with all of you, or we're going to continue our lecture session with the lecture 2 of 3, or topic of 6 polynomials, 6.2, remainder theorem, factor theorem, and zeros of polynomial. Okay, now, please refer to your lecture notes. So, we're going to look at the key of this topic, subtopic here, relate the remainder and factor theorems to solve the problems. First key word, and the next is the find the root and the zeros of the polynomial. Okay. So I'm not going to discuss or explain much on this. We're going to look at example. It's getting more clear then. Okay, so you may read all this. We call if the polynomial px divided by x plus a, then the remainder equal to p x equal to negative a, and also this one here. Okay. Example 1. Okay, now from a definition, meaning that for this one here, polynomial of x equal to negative 3, and we're going to find out what is the remainder. Find the remainder when the polynomial is divided by this one here. So x equal to negative 3 from the factor of x plus 3, then x equal to negative 3. So we're going to we call substitute 2 negative 3 cube minus 6 negative 3 square plus 4 times negative 3 and plus 3. So negative 3 cube, negative 27 times 2, negative 54. Negative 3 square equal to 9, and negative 3 square equal to 9 times negative 6, negative 54. 4 times 3 equal to negative 12 and plus 3. So negative 54 minus 54, negative 108. Minus 112 equal to negative 120, plus with 3, then it is equal to negative 177. Or 170, sorry. And polynomial when x equal to, from here, then the value of x equal to 1 over 2. So x, polynomial of x equal to 1 over 2, as we call, we substitute into an x, 2, 1 over 2 cube minus 6, 1 over 2 square plus 4 times 1 over 2 plus 3. So 2 1 over 8 minus 6 1 over 4 plus 4 divided by 2 equal to 2, 2 plus 3 equal to 5, and you have your calculator with you, and this will give you the total of 15 over 4. Okay, now when this polynomial of px 5x squared plus x minus 8k is divided by x minus 1 dx, then the remainder is 2, determinant of k. So p1 equal to the remainder equal to 2. So substitute x equal to 1, 5, 1 square plus, 5, x equal to 1, x here, 1 minus 8k equal to 2. So 5, 1 square equal to 1 times 5 plus 1 equal to 6 minus 8k equal to 2. Negative 8k equal to 2 minus 6 equal to negative 4. Then k equal to 1 over 2. Okay. Therefore, that's solution for example 2. Now, the polynomial of px gives a remainder of 1 when divided by x minus 2 and a remainder of 3 when divided by x plus 2. Determine the remainder when px is divided by x minus 4. Okay, so let's take a look at the first definition here. The polynomial of px gives a remainder of 1 when divided by x minus 2, meaning P2 equal to 1. Okay. Divide by x minus 2, so that x equal to 2 and the remainder is 1. And then, when divide by x plus 2, in this case, then the value of x equal to negative 2. And the remainder equal to 3. And it mentioned that the px is divided by x squared minus 4. In this case, if this is the divisor of the px, okay, x squared minus 4, look at that. We call the power of x for this divisor, which is x squared. So then the remainder of Rx, the degree of x must less than 1 from the divisor. So this one come out with ax plus b. Okay, and we're going to use the definition of R2 equal to P2 equal to 1. So the remainder ax plus b, then substitute with x with 2. Okay, substitute the x with 2 here. So they come out with 2a plus b equal to 1. Then also the definition from the previous, the remainder of x or negative 2 equal to the polynomial when x equal to negative 2 equal to 3. And then substitute x with negative 2 here, they give you negative 2a plus b equal to 3. Equation 2. So then, from equation 1, equation 2, we're going to solve by using a simultaneous equation, whether substitution method or elimination method. So then, equation 1 minus equation 2. So look at the both of equation, we got b and b. So I'm going to eliminate the b. 2a plus b equal to 1 and negative 2a plus b equal to 3. Okay, so then b minus b equal to 0. Negative times negative, positive. So 2a plus 2a equal to 4a equal to 1 minus 3 equal to negative 2. So then a equal to, okay, bring up here, negative 2 divided by 4 equal to negative 1 over 2. And substitute a, substitute a into equation 1. Okay, so then 2 times negative 1 over 2 plus b equal to 1. 2 divided by 2, then negative 1 here, so then b equal to negative 1 will become positive, so 1 plus 1 equal to 2. Okay, then the remainder of this equal to, when a equal to negative 1 over 2, so negative 1 over 2, okay, sorry, ax plus b, or the remainder is negative 1 over 2 x, and b equal to 2. Okay. Now, the factor theorem. So when PA equal to 0, then x minus a is a factor of px. Okay, so that show that x minus 2 is a factor of this polynomial. So this is the polynomial of function of px and given here, and this is the factor of divisor. So if this is a factor, meaning that P2 is going to give you 0. Okay, now let's try. P2 equal to 2 cubed minus 4 times 2 squared plus with x equal to 2 plus 6. So 2 cubed equal to 8. 2 squared equal to 4. 4 times negative 4 equal to negative 16. 2 plus 6 equal to an 8. So can you guess what we find the answer given then? Yes. 8 plus 8 equal to 16 minus 16 equal to 0. So we can just come up with the conclusion that x minus 2 is a factor of polynomial px. Okay, then next question here, when px equal to 3x cubed minus ax squared minus bx plus 1 is divided by x minus 2. Okay, when this polynomial divided by x minus 2, then the remainder is 15. So we may come up with one conclusion, okay, one information here. P2 equal to 15. And x minus 1 is one of the factor. X minus 1 is one of the factor, meaning P1 equal to 0. Determine the values of A and B. Okay, now, so you can see here now we call the polynomial given then, and these two from the info we call from the questions then. So the question wants us to find the value of A and B. So substitute P2 equal to 15. Okay, from here 2 cubed minus A 2 squared minus B times 2 plus 1 equal to 15. So 2 cubed equal to an 8. 8 times 3 equal to 24 minus 2 squared equal to 4a minus 2b plus 1 equal to 15. then negative 4a minus 2b equal to 24 plus 1 equal to 25. Okay, 24 plus 1 equal to 25. So bring 25 to the other side, become negative 25. So 15 minus 25 equal to negative 10. And divide by 2, it gives you negative 2a minus b equal to negative 5. So equation 1. Then P1 equal to 0. So 3 times 1 cube minus a times 1 square minus b times 1 plus 1 equal to 0. 1 cube equal to 1 times 3 equal to 3. 3 plus 1 equal to 4. Minus a minus b equal to 0. Then negative a minus b equal to negative 4. Okay, so bring 4 to the side, become negative, multiply with negative 1, here become a plus b equal to 4. Equation 2. Okay, so now look at the equation 1 and equation 2 here. We got negative b and also b. If I make this one as equation 1 plus equation 2, negative 2a minus b equal to negative 5, and also a plus b equal to 4. Okay, plus here, negative b plus b equal to 0, negative 2a plus a equal to negative a, negative 5 plus 4 equal to negative 1. So then a equal to 1. And substitute a equal to 1 into equation 1 or equation 2. So I prefer equation 2 because it's we call the simplest one. A plus b equal to 4. So substitute this into equation 2. So 1 plus b equal to 4. Then b equal to 3. There you go. Okay. So the value of a equal to 1 and b equal to 3. Okay, now if pa equal to 0, then a is the zeros of the polynomial. Okay, so let's say given to us the polynomial of px, and we can factorize, and we get all 3 factors here. Then we come up with a conclusion that negative 1, 2, and 3 are the zeros of the polynomial. Okay. And the root px, okay, given a polynomial of px equal to 0, where we factorize, and as you see here, then we come up with a conclusion that x equal to negative 1, x equal to 2, and x equal to 3 are the roots of the polynomial px. Okay, so let's take a look at example here. Okay, so given px, show that x minus 1 is a factor, factorize completely, find all the zeros, and find the roots of px. Okay, so what is the 3x cubed plus 7x squared? Example 6. px equal to 3x cubed plus 7x squared minus 2x minus 8. Let's double check. 3x cubed plus 7x squared minus 2x minus 8. There you go. So the question is, show that x minus 1 is a factor. So means that P1 equal to 3, 1 cube plus 7, 1 square minus 2 times 1 minus 8. Okay, so 1 cube times 3 equal to 3 plus 1 square times 7 equal to 7 minus 2 minus 8. So 3 plus 7 equal to 10. Negative 2 minus 8 also give you negative 10. So 10 minus 10 equal to 0. So x minus 1, we come up with a conclusion that x minus 1 is a factor of polynomial px, given that. Okay, next one, what's the question? Factorize px completely. So it means that here 3x cubed plus 7x squared minus 2x minus 8 equal to, okay, so this one of the factor of the zeros that we have done, we call completely the task here. So x minus 1 and, okay, class, the highest degree here is 3 and one of the factor is linear 1. So here I come up with ax squared plus bx plus c. Okay. Okay, so now we are going to expand this. Okay, ax squared times x, it gives you ax cubed. Then bx times x plus with bx squared plus with c times x equal to cx. Ax squared times negative 1 minus ax squared plus with bx times negative 1 minus bx and negative 1. Negative 1 times c equal to negative c. Okay, so then ax cubed plus with, okay, bx squared and negative ax squared. So come up with b minus a x squared plus with negative b, okay, negative bx and also cx. Negative b plus cx minus c. So we are going to compare all this with this px. So we can see clearly here that ax cubed with 3x cubed. So then a equal to 3. Negative 8 with negative c. Negative 8 equal to negative c. So then c equal to 8. So the next, okay, look at the coefficient of x squared, compare b minus a, where a equal to 3 equal to coefficient of x squared equal to 7. Then b equal to 10. And also, okay, b equal to 10, c equal to 8. So then negative 10 plus 8 equal to negative 2. Clear that. So then 3x cubed plus 7x squared minus 2x minus 8 equal to x minus 1. Okay, look at this one here now. A, what is the value of A? Yes, a equal to 3x squared, and b equal to 10 plus 10x, c equal to a plus a. Okay, so you may use the calculator or just thinking of how you're going to factorize this using factorization or using the formula. So I give you the answers here, x minus 1. Then next factor, linear factor is 3x plus 4 and x plus 2. So from here, the zeros are The zeros are 1, negative 4 over 3, and negative 2. And look at the question of D then. Okay, find all the zeros and find all the roots of Px. So then the roots are x equal to 1, x equal to negative 4 over 3, and x equal to negative 2. Okay, so that's solution for question example here. And now, negative 1 is one of the zeros for a polynomial, and Px is divisible by x minus 1. Okay, class, what's the difference between this one sentence here? Negative 1 is one of the zeros, and Px is divisible by x minus 1. Okay, to define this, negative 1 is one of the zeros means that P negative 1 equal to 0, and Px is divisible by x minus 1. So for this is actually that P1 equal to 0. Looks like the same, right? Okay, find the values of m and n and find all the roots of Px. Okay. Okay, so let's write down the polynomial, the function again. Px equal to x to the power of 4 plus mx plus n, okay, cube here, and x squared minus x plus 6. Let's double check. X power of 4 plus mx cubed plus nx squared minus x plus 6. Okay, and as mentioned that here, negative 1 is one of the zeros and also divisible by x plus 1. So it means that here P1 equal to 0 and also P negative 1 equal to 0. Okay, so then substitute x equal to 1. 1 power of 4 plus m1 cube plus n1 square minus 1 plus 6 equal to 0. Okay, m plus n. 1, this is 1. 1 minus 1 equal to 0. Plus 6 equal to 6. Bring to the other side and it becomes negative 6. Equation 1. Then negative 1 to the power of 4 plus n negative 1 cube plus n negative 1 n squared minus negative 1 plus 6 equal to 0. Okay, so negative 1 to the power of 4 equal to 1. This becomes negative 1 cube, negative, so plus times n minus m, and then negative 1 square equal to positive plus n, negative times negative, positive 1 plus 6 equal to 0. Okay, 1 plus 1 equal to 2 plus 6 equal to 8, so negative m plus n equal to negative 8. Okay, so what's the question just now? Find the values of m and n and find all the roots. Okay, now we're going to find out the value of m and n. There are two equations, equation 1, equation 2, and the variable of m and n. So we may use equation 1 minus equation 2, m plus n equal to negative 6, and also negative m plus n equal to negative 8. So n minus n, 0, m, negative times negative become positive. So n plus m, 2m equal to negative times negative equal to positive. So negative 6 plus 8. 8 minus 6 equal to 2. Then n equal to 1. So then substitute n equal to 1 into equation 1. Okay. So m equal to 1, 1 plus n equal to negative 6. Then n equal to negative 7. Okay, so now let's rewrite all this. Okay, where x power of 4 plus m equal to 1, x cubed, n equal to negative 7 minus 7x squared minus x plus 6 equal to, okay, so from this and this, then we know that it is factors of x minus 1, x plus 1. Okay, x times x equal to x squared. But what we have here is x to the power of 4. So it means that here come out with ax squared plus with cx plus d. Or this one, we come up with x squared minus 1 and ax squared plus, okay, so if I write that this one as okay, ax squared plus bx plus c. So bx plus c, okay, then ax squared times x squared, ax to the power of 4, then bx times x squared plus with bx cubed, and c times x squared plus with cx squared. Then ax squared times negative 1 minus ax squared, bx times negative 1 minus bx, and c times negative 1 minus c. Okay, so now ax power of 4 plus with, okay, plus with bx cubed plus with negative a plus with c x squared minus bx minus c. Okay, we're not gonna recall enough space here. If you use the method that I showed with the previous example, you may find out the conclusion that you compare the one on the right side with the recall, the one on the other side. Okay, please refer to this. Okay, the previous example I showed you just now. So we may come up with a conclusion that A equal to, okay, ax power 4 with x power 4. So then A equal to 1. Minus C here. C, negative C equal to 6. Negative C equal to 6. So then C equal to negative 6. What else? B. B cube. B cube and we have 1x cube here. So then B equal to 1. Okay. So A equal to 4, A equal to 1, B equal to 1, and C equal to negative 6. So then it come out with x squared minus 1 and ax squared plus bx plus c, where a equal to 1, x squared, b equal to 1, plus with x and c equal to negative 6, or equal to x minus 1, x plus 1, and for this one here, x plus 3 and x minus 2. Okay, so then the roots are x equal to 1, x equal to negative 1, x equal to negative 3, and x equal to 2. There you go. Example A. Find all the roots of this polynomial of x cubed plus 3x squared plus x minus 1. Okay, for this question, it did not give you any single roots or zeros, meaning we need to find at least one of the roots by inspection or by try and error. So let's try with x equal to 1. Okay, so then P1 equal to 1 cube plus 3 1 squared plus 1 minus 1 equal to 0. Okay, so 1 minus 1 equal to 0, 3 times 1 squared equal to 3, plus 1 equal to 4, which is not equal to 0. So x minus 1 is not a factor of this polynomial px. Okay, so let's try with x equal to negative 1. So negative 1 cube plus with 3 negative 1 squared plus negative 1 minus 1. Okay, negative 1 cube equal to negative 1. Negative 1 squared equal to 1 times 3 equal to 3. Negative 1 minus 1 minus 1, then it equal to 0. So then x plus 1 is a factor of polynomial px. Okay, so then our next question here is we are going to, okay, now x cubed plus 3x squared plus x minus 1 equal to, okay, this is one of the factor, then x plus 1, then the other one here is ax squared plus with bx plus c. Okay, now let's compare. When ax squared times x, it gives you ax cubed. Bx times x plus with bx squared plus with c times x equal to cx plus with ax squared times 1, ax squared. Bx times 1 equal to bx, and c times 1 equal to c. Then ax cubed plus with x squared and also x squared. So a plus b x squared. Then for coefficient of x, we got b and c. So then b plus c x plus c. So from here, we compare the one on the left side with one on the other side. So a equal to 1. C equal to negative 1. And what about B? Okay, A plus B equal to 3, where A equal to 1. So 1 plus B equal to 3. So then here B equal to 3 minus 1 equal to 2. Okay. Now, from here, it gives you x cubed plus 3x squared plus x minus 1. X cubed plus 3x squared plus x minus 1 equal to, the first is x plus 1. X plus 1, and then a equal to 1. A equal to 1, so x squared, and b equal to 2. B equal to 2 plus 2x, and c equal to negative 1 minus 1. So then here we factorize as x plus 1. Okay, let's find out the other two factors here, x squared plus 2x minus 1. I don't think that we can factorize this. Okay, this is one of the quadratic that cannot be factorized. Okay, this is one of cases that x squared plus 2x minus 1 cannot be factorized. In this case, we are going to use the formula x equal to negative b, where this one here, a equal to 1, b equal to 2, and c equal to negative 1. Okay, negative b, negative 2 plus minus square root of b squared, 2 squared minus 4a, and c divided by 2a, where a equal to 1. So from here, we can come up with a result of negative 1 plus minus square root of 2, which means that the x equal to negative 1, okay, this here, which is negative 1 plus square root of 2, or negative 1 minus square root of 2. So the roots are x equal to negative 1, x equal to negative 1 plus square root of 2, and x equal to negative 1 minus square root of 2. Okay? So the conclusion here, the remainder theorem, polynomial px is divided by x minus a, the remainder is pa. Okay? So you see here, and also okay, so you may just read it all from your notes. That's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Until we meet again.